Back Math 9. Today we are going to learn about multiplication of polynomial part 2. Last time we learned about multiplication of polynomial when you have constant outside. So that type was something like a bx plus minus c, something like that. Or we also learned a bx squared plus minus cx plus minus d, which is a fancy way of saying this is binomial. It can be something x plus c, something else minus something. And it can be any of a number, a, b, or c. It's like 3x plus 3, 4x minus 1, those kind of thing. And we also learned that monomials outside of the bracket, and then you need to do something like 5 bracket 6x squared minus 3x plus 1. Bracket close, something like that. Long story short, both of the situation, we know that monomial was constant. It has no degree. Degree was 0. But at the same time, when it comes to constant, those are just a whole number or integer, positive or negative number. We learn about this in two different ways. One way we use, as you may remember, integer tile. One without tile. Today, what we're going to focus is, again, whether you like it or not, tile methods come back, but the format of polynomial look like this. I call it generic expression, ax, bracket open, bx plus minus c. This is a special type of multiplication that we are going to learn, and we are going to start using algebra tile first. Before we getting into an actual lesson, I want you to look at the difference between what we learned so far versus what I just wrote. What's the difference? The difference is located outside of the bracket, which is my monomial. This time, my monomial is not necessarily a constant. It is actually has some kind of variable having term. Then what can we do to figure out our expansion process and how we can use algebra tile to lead to that multiplication? Here's what I want you to understand for the rule. Imagine if you're multiplying x by x. If we use algebra tile, if you remember, x, it's positive x, so it's just an empty strip, and another empty strip over here. This is my x, that's my x. We learned in the first unit, when we first learned about rational number, the exact same type of number if you multiply, like 2 times 2, that's 2 squared. Same thing happen if it's variable too, like y times y is y squared. So x times x is x squared. This is what we learned so far in September. One thing that you need to remember is how can this apply for an algebra tile? If I combine strip by another strip, here's one thing that you need to know from now on. You will create x squared big tile. The reason being is, imagine the horizontal one is like width and vertical one is like length. So if I multiply width by length, it gives you square. And the reason that is square is because x and x, it's the same width and same length. So you may notice that there is a new rule that you need to apply. However, if you're dealing with a situation where I have a color strip that's negative x, and you have non-colored one or empty one, which is just positive x, then color and non-color, that rule apply the same like previous one. Color and non-color give you color one, which is negative. So the only thing that is different between the first example and second example is the combination of color tile. If I have negative and negative, then you're going to have positive. We're going to go through each of the example using that rule. So I like to say positive times positive give you positive. It's a little recalling. Negative times negative give you negative. Oh, sorry, positive. There you go. Call it same signs. We learn about this in Unit 3 when we learn about rational number. And as you may notice, positive and negative, if you multiply, give you negative. Negative and positive, give you negative. Without further ado, let's do classic example. First thing first, I want you to look at the example. X bracket x plus 1. So as you may notice, we have binomial and monomial. It doesn't matter where you put anything. Generally, I put monomial as a vertical grid. Remember making a table? And as you may notice, I'm using an empty strip. X plus 1 is a fancy way of saying one empty strip and one tiny integer tile. Now let's think about it. X and x give you x squared, which is fancy way of saying big square, and it's empty, empty, positive, positive, give you positive, right? Although it's not necessary, but sometimes people benefit. If you have just empty one, that's positive 1 and x. X times positive 1, it's just fancy way of saying one strip. This is a step number 1. Setting up horizontal and vertical. Step number 2, combination. Step number 3 is finding out any zero pair and then combine the expression. So far, we do not have any of a zero pair. It's actually just one big x square tile and then just another strip, which is x. So my final answer is x squared plus x. That's it. We are going to look at some tricky ones as time goes, but that's something that I want to point it out. Next one, as you may notice, monomial versus binomial, negative 2x. Now we gotta think about our colored strip. 2x, negative 2x is a fancy way of saying I have to build two colored strip. Again, doesn't matter whether you put it on the left side or right side, but long story short, it's just my OCD. I prepare monomial on the vertical side and the polynomial on the other side. But again, it's your call. X minus 2, fancy way of saying empty strip, and then two colored integer tile. Now, we have x times x. That's an x squared, which is big square over here. Same thing over here. However, do we need to fill it or make it empty? Positive and negative give you negative, so color it. Positive and negative give you color, so color that too. Other part, negative 1, negative x. It is a strip, but will it be empty or color? Negative times negative give you positive, so empty. So we did our first step, second step, third step, combination, which is I have two color squares, so negative 2x squared plus 1, 2, 3, 4, the empty one, positive 4x. And that's it. Negative 2x multiplied by binomial x minus 2 is equivalent as negative 2x squared plus 4x. That's how things work in the world of algebra. Let's see. Next example, negative 2x bracket 9 plus x. Same setup. Negative 2x means one of the color strip and another color strip. Note the fact that I'm vertically putting the monomial. 9 plus x, this is quite tricky just because we have lots of number going on. And I'm kind of regretting putting this example because I gotta draw a lot. In any case, 9 empty integer tile, because that represents positive 9, and 1 strip, empty strip. Positive and negative give you negative, so first thing first, I gotta draw all of the strip. Yeah, that's a lot, by the way. Hopefully next example seems pretty straightforward. Just this nasty example, folks. One, two, three, four, five, six, 7, 8, 9. Although it's tedious, you guys need to be familiar with this method because trust me, grade 10 math, it's gonna get even nastier when you go in high school. And we have x squared, except positive, negative give you negative. That was a big journey for one question. However, now our last step is count everything. I have 2 big squares, so that means negative 2x squared minus. The reason I put minus is because everything that I see is a color strip. So I have 9 and 9, so what is that? 18x. This example is a good example why. Next class, we're going to learn about how we can move away from tile, because as soon as you go a higher number, it just takes a long time. Last example today, negative 3x, x minus 4. So at this situation, actually second from the last, I actually have one more example, sorry. But in any case, negative 3x is color strip, and another color strip, so 3 entire color strip, x minus 4, empty strip, color. So, in that situation, positive and negative give you negative x squared, same thing. Then empty strip for these guys. The last step is count everything. I have 3 color square and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 empty strip. So negative 3x squared plus 12x is what I have. So far, all of these examples do not have a zero pair. So some people may wonder, will I never get zero pair? Well, using the multiplication rule, most of the time you're right, you don't have it. However, there will be some situation, and this is a little bit of a boundary where we go between grade 9 math and grade 10 math. There is a situation that zero pair can happen. So let me create a certain example. Let's say 3x and minus 4x plus 5 plus 2x minus 3. As soon as this happened, first reaction that I get from the people is, we cannot solve this problem, Mr. Kim, because I have monomial outside, but inside, every example that we have been dealing with was binomial. Fancy way of saying 2 terms. Right now we have quadruple, 1, 2, 3, 4 different ones. My approach is, well, think about it. This is just apply situation. You have polynomial. You have monomial. It is still under the same category of today's lesson. It's just gonna be more drawing. So, here's what I'm going to do. 3x, that means 3 empty strip. Voila. Negative 4x. This is where things are getting a little tricky just because of the number of drawing. And 5, 1, 2, 3, 4, 5, positive 2x, that's a 2 strip, and 1, 2, 3. There is an easier way of dealing with it, but still, let's just go through each of them traditionally. Empty one and colored one. So that means I gotta have a colored square. Let me just do this first. Same thing for the second column, third, fourth, and positive x, positive 1, just an empty strip. Positive x give you positive x squared. It's a big one. And we're almost at the end. Positive and negative give you colored. And obviously it's x and negative 1, so color strip. You don't see this kind of question a lot at all. However, this is a good example where zero pair occur. Like, can you see that I have negative x squares and then positive x square over here? So, let's do a process of elimination. Like, as you may notice, I am canceling some of those positive and negative pair. We call it zero pair, right? Three color, 3 empty, 3 empty, 3 color, 3 color, 3 empty. So, as together, let's make everything into descending order. I have 1, 2, 3, 4, 5, 6 colored one. So that's a negative 6x squared. And then, when it comes to strip, I have 1, 2, 3, 4, 5, 6, positive 6x. Is that everything? Let me just 1, 2, 3, 4, 5, 6. Okay, good. 1, 2, 3, 4, 5, 6. Good. So my final answer is negative 6x squared plus 6x. Ladies and gentlemen, that is today's lesson. I want you to work on the homework question that I'm giving you shortly after. I want you